Hi, today we'll be making a tutorial on finding the density of a few objects. We will be teaching you how to find the density of a regular object, like for example, a block, an irregular object, for example, a stone, and also a third object that uses a different apparatus from the first two objects. Without further ado, let's begin. For this tutorial, we'll be using the SI unit grams, cm cube, and grams per cm cube. Firstly, we will demonstrate how to find the density of a regular shaped object, like a cube or sphere. For this demonstration, we'll be using a Jenga block. To calculate density, the formula is density equals to mass over volume, which means that the mass of the object divided by the volume of the object will give the overall density of the object. Hence, in order to find density, we will need to know the mass and the volume of the block first. To find the mass, place the block on an electronic balance. Ensure that the reading on the balance is 0 before placing the object on it, and also only take the reading down after the number has stabilized. Repeat this process at least 3 times and use the average mass to ensure accuracy. Record all these readings in grams. In this case, the 3 readings recorded were 15.3, 15.4, and 15.4. From these readings, we will be able to come out with an average of 15.4 grams. This is corrected to 3 significant figures. To find the volume, the block needs to be measured for its height, length, and breadth. Use a ruler to measure the height, length, and breadth. Take these measurements at 3 different points on the block, as the block may have a slight irregularity at different parts. Take the average of those 3 measurements to ensure accuracy. Multiply all the average final values of the length, width, and breadth to find the volume. Take all of these measurements in cm cube. So, as d equals to m over v, the density will be equal to mass over volume. Divide the mass obtained in part 1 in grams and divide it by the volume obtained in part 2 in cm cube. The result will be the density in terms of its SI unit, grams per cm cube. Now, let's move on to part 2.
To demonstrate the finding of density of an irregularly shaped object, we will use a small pebble. This object is not of a regular shape and hence the volume cannot be found by mathematical calculation. Again, as d equals m over v, we need to find the mass, then the volume of the pebble to obtain the density. Like the previous experiment, we will use the SI units, grams, signified by g, and cubic centimeters, signified by cm cube. In order to find the mass of the pebble, we can use the same method as finding the mass of the block in the previous experiment. Place it on the electronic balance and wait for the number to stabilize. Then, record the mass reading on the balance. Now to find the volume of a pebble. It is not regular shape, so it cannot be calculated by mathematical formula, like a box or a ball. Instead, we have to use Archimedes' method, through displacement calculation. To do this, we need a displacement can and some string. Fill the displacement can with water all the way to the mouth of the displacement tube. Place a measuring cylinder directly under the end of the displacement tube. Next, we have to tie the pebble with the string, such that one end is long enough to lower the pebble into the water. Do this slowly to prevent splashing, which will cause an inaccurate measurement. Even though the string has volume, this can be neglected as it is minimal. When the water stops flowing, carefully read the measurement on the measuring cylinder. Ensure that your eye is directly level with the water level in the measuring cylinder, which should be placed on a stable, parallel surface. The water level in the measuring cylinder will have a curved look, called a meniscus. Be sure to take the reading from the lowest point of the meniscus, the middle. Repeat this experiment at least 3 times and record down all the volumes of water in the measuring cylinder. Take the average water level for a more accurate result, and this value will be the volume of the pebble. To find the density of a pebble, take the mass recorded divided by the volume to get the density.
Now, let's move on to part 3. Again, to find density, the formula is D equals to M over V. A coin is in the shape of a cylinder with a circular exposed surface area, and the total volume can be calculated using the formula pi r squared times height. This will allow us to successfully find the volume of the coin. In order to find a mass, we have to use an electronic balance just like the previous objects. First, we have to make sure that the electronic balance begins with nothing on it and the reading is 0, just like the previous experiments. Then, place the coin on the balance and wait for the value of the balance to stop fluctuating and come to a stop. Do this 3 times to find the average. Next, we have to find the volume of the coin. To get the volume, we will first need to use a vernier caliper to measure the radius of the coin, which is the diameter divided by 2. Take note, we must take the diameter of the coin from 3 different sides and find the average of these readings to increase the accuracy of the measurement. Then, use the formula pi r squared times height to find the volume. Finally, take the mass of the coin in grams and divide it by the volume in cm cubed. The density will then be found. With this, we would like to wrap up our tutorial. We hope that this has helped you in some way, and thank you and new Cine Labori.